the different agenda and topic that we would be covering, but I just wanted to kind of touch a little bit from a high level on those topics, then leave it to Zahur to walk us through it. So just quickly, team, before we try to understand why enterprises are modernizing their application and why are we, this topic is very hot these days, and one of the topics that keeping all CIOs awake at night. So let's try to first define what application modernization, okay? Because everybody has this different concept of their mind and a different definition. So I wanted to kind of summarize it for people who are very new to this topic and people who are familiar also to have a common ground on how we see application modernization concept. So you need to think of it as mainly like a practice of updating an older software for a newer computing approach. So this could include a newer language, a newer framework, or even an infrastructure platform. So this practice sometimes is called like a legacy modernization or a legacy application modernization. Think of it as a software development equivalent like of re-innovating your older home. So you're trying to take advantage of improvement to efficiency, to safety, to structural, and so forth. So rather than just retiring an existing system or replacing it as a wholesale, application modernizations extends like the lifespan of this application and make it take advantage of the technical innovation. So this is just trying to highlight what application modernization concept for people who are new to this topic. So why are people considering application modernization? Why enterprises are looking into this? So some of the desired outcome that we get from the enterprises and the different people that we work with, the first thing is to do really mainly with the growing their revenue. Okay, so they're really under a heavy pressure to kind of provide like some sort of a compelling digital experience for their customers. This concept to cash application pressure. So I want to be able to take this concept and convert it into a code quickly. This idea coming from my client of interest of some sort of topic, how can I convert this into a reality quickly, okay? And not only that, but make it a rapidly iterate. So I'm able to make changes and make updates on the fly. You know, I don't have to go through this old, long release cycle to make any changes to my code, but I'll be able to make changes instead of days, in hours, and sometimes minutes. So this is one of the desired outcomes that the enterprises are looking into. That also, the second one is to do with the increased number of cyber attacks and the vulnerability that we're seeing everywhere. So pretty much the apps is running everywhere. You have many applications you're carrying in your hand. You have an entire database of critical information, which is your phone. You have applications running in your kitchen, in your car, etc. So it is difficult to innovate at pace and scale whilst trying to protect the software. So how can I build this software with the embedded security from the beginning? And last but not least, another desired reason for these enterprises to modernize is basically they want to take advantage of all this innovation that are provided by the different cloud providers out there. So those are three main reasons that we have there. And for these specific reasons, it's not surprising to see a lot of the executive, and we have two studies and two results here. A lot of the executive have their, or CIOs have the application modernization as one of their top priority project. So 78% of the people, and based on a study of 2020, have the application modernization as top priority for them. This number has increased even above 90% in 2021. But you see there is a percentage that's shown 48%, and this is taken to the number of last year, 48% have made any progress on that. And the reason for that is not because they don't want to, it's because this is more like a journey. This is not only a set of capabilities or like a tools that you plug in there and you have an application modernization. This is a change of a culture, a change of a mindset, and more like aligning between specific stakeholders and people within the organization. So some of the common reasons that you will see that making it challenging to some of the clients is basically each application in the portfolio has different requirements for scaling up, scaling down, scaling out. And when you have a legacy infrastructure there, it makes it difficult and expensive to support. Another reason, basically, there are an overwhelming number of choices that each team can make when assembling a platform capabilities. And the last but not least, you would notice that most of the important applications, like in the banking, etc., are a monolith legacy applications. So there are millions of codes there, something like a dinosaur code. It's hard to change, difficult. So that's another challenging reason that they're facing, and this is slowing their journey. So it is important to remember that more and more businesses are using, custom application to interact with their customers. So custom application have really become the central to revenue generation, just like we touch about concept to cash. How can I take this idea and convert it into a code quickly? Brand identity, this is very important. I could be Mercedes selling the best cars out there and I have the best website, but if I have a crappy app and a bad app, this is gonna ruin my brand identity. And last is the user experience, okay? So, and if anything that proves what I just mentioned, if you look at it from last year, whoever had made a progress on their application, and because of work from home and the heavy relying on the applications, whoever had their modern app ready to handle that situation, survived, while others had a tough situation there. So VMware have put together this most flexible portfolio of products and services for modernizing your application and your infrastructure. Okay, it is a set of products and services to help you not only build and run, but also manage your application on Kubernetes and multi-cloud. So it is designed to simplify, as it's mentioned in the slide, to simplify multi-cloud operations while freeing the developers, okay, to move faster by giving them like access to different resources that would help them build the best applications. And also, and very important, we are with the portfolio trying to help bring those development and operation team, the DevOps type of concept, teams together under a shared goal of fast release cycle. So we want to get these guys and break the wall between them and help them work together. All of that surrounded by skills and expertise that we bring also. So just like, remember, as I mentioned, this is not only a magic stick and a set of tools that you just install and things would work magically. No. So we have the VMware Tanzu works hand in hand with the Tanzu Labs to help you master a modern way of building and operating software. So VMware Labs or Tanzu Labs has 30-year track records of enabling software transformation with over 2,000 successful projects with major names. So we don't only work from an application top-down approach with you, where we help customers, for example, tackles complicated business challenges that often span multiple departments and line of business. We also can work with you on the infrastructure part, okay, where, for example, we can help you with the installation. We pretty much represents an ideal solution for situation, okay, where you need the tactical help, installation, customization, integration, etc. Last slide before I hand it over to Zahur, just a quick reminder on what I mentioned earlier. Again, leaders are not really waiting for this. They have a tough pressure, and you saw the percentage of number that of CIOs has made the application modernization as top priority for them. So, and also the IDC, and this is from last year, but I think these numbers will even increase further, but they have made a bold projection that in a few years, you would have 2/3 of enterprises actually deploying codes on a daily basis, okay, fully embraced by the cloud native patterns. So how do you ensure you are in the 2/3 and not laggard behind? And this is how will Zahur explain to you what VMware is doing and getting a bit deeper into the portfolio. Zahur, I'll hand it over to you.
Thank you, Salim. Thank you very much. Wonderful. So let me share my screen. and please let me know. I think you have to stop sharing first, Salim.
Sure, I'll do that.
Okay, great. So please let me know that you can see my full screen presentation.
Yes, we can see it though.
Perfect. So I think I'm going to, you left this discussion at numbers. I'm also going to throw some numbers, but I'll take a different angle because I will come to the Tanzu portfolio and Tanzu Kubernetes grid, but I think it's very important to understand the reason behind, why this drive towards modernization, modern application platforms, and obviously this cloud native application architecture. So I think you can see that there is definitely a trend towards a rise towards application modernization, and our estimates, one of these studies that we did, which shows us that 2024, more than half of these applications are going to be what we call the modern applications. Modern applications are basically cloud native applications. It's also through our own interaction with our own customers in the region shows us that a majority of the executives in C-level executives are looking at modernizing their monolithic legacy applications to these cloud native application architecture. So this modern application, I think the definition of a modern application has changed completely. So underlying this idea of a cloud native application are three basic concepts, right? And we need to understand what this modern application is made up of to then later on, see what kind of platforms and services we need to run them. So the basic idea behind a cloud native application is that of a microservice or microservices based architecture. And what this really means is that we are moving away from monolithic application architecture where you had an application which was coupled tightly together, and all the different components of the applications were interacting with each other in a very tightly coupled fashion. Microservices, on the other hand, is a loosely coupled design where you have a larger application which is broken down into smaller modules. Each of these modules is communicating with the other microservices over the TCP/IP network. It's not necessarily on the same system, possibly not even on the same clusters, and in some cases not even in the same physical infrastructure or in the same cloud. So the reason behind these microservices is that it allows developers and software creators to update and upgrade their modules independently of other microservices, so they can go ahead and make some innovation or possibly patch their application without affecting rest of the services running in to serve a particular business application. This is the reason behind this the popularity of microservices architecture. Now, on the other hand, one of the reasons containers has, especially, we always hear about Docker containers. One of the reasons that this idea of containerization has picked up is because it has become the packaging of choice for these microservices. So when you are developing these microservices-based applications and you want to package them and deliver them to your customer, then the format or the packaging for these microservices is going to be containers. And the third, major point here is about the multi-cloud architecture. When you build these type of applications and when you containerize them, one of the inherent benefits of this architecture is that it is going to be multi-cloud. So you can easily move these microservices across different platforms and architectures without necessarily having to rewire or rewrite these applications. So this is the definition of a modern cloud native application. Now, the fundamental change that is happening behind this is basically, that we want the developers to focus on their own application or their own intellectual property or innovation. So the less they do, the more the system does for you. And this is the big shift that is taking place as we speak right now. When we talk about modern application platforms, we are relying on the platform itself to provide us with most of the services that in the past would have to be coded by the developer. Now, in this new scheme of things, your developer is focused only on the application, his or her own application code, and the system or the platform is going to provide everything else that is needed to put this application into production, including all the automation from start to end. So one of the key enablers of this modern applications is Kubernetes. I'm sure all of you would have heard about Kubernetes. Many of you will be experts on Kubernetes already. And again, when you speak about Kubernetes, the numbers are there for you to see. It has, there's a significant increase in adoption of Kubernetes as a platform of choice for running containerized applications. And the reasons for this, there's several benefits, several advantages. My personal favorite, obviously, is this shortened software development cycles. I'll come to this later on. But there are other advantages. Obviously, the improved resource utilization, the ease with which you can upgrade and maintain your applications. There are also the containerized monolithic applications, the applications which you cannot necessarily turn into microservices. So there are many benefits of that Kubernetes brings, but again, it essentially boils down to writing and creating and running your modern applications on this platform. So Kubernetes, one of the big advantages of Kubernetes is that it offers you an abstraction from the physical infrastructure or the cloud architecture on which you're running. This is one of the inherent advantages, and this is why the Kubernetes has become so popular among DevSecOps community. So as you can see, there is different types of infrastructure on which you can run your Kubernetes. It will provide you a layer of abstraction. And the big idea behind this is that as a software developer, you do not need to worry about the underlying infrastructure and all the services that it can offer. What you need to learn as a developer is a Kubernetes API. And Kubernetes API will offer you all the resource types, all the objects that you need to build your modern application, to package it, and to be able to run it on a Kubernetes cluster. So once you have built your application, you've built your application manifest files, you've created your container images, then you are free to really run them on any type of cloud architecture underneath without necessarily changing anything in your application or the manifest files or how it's going to be deployed in any of these target clusters. Now, one of the other points that I must mention here is that Kubernetes is a little different from many other configuration management tools out there, many other deployment methods. It is not an imperative system. It is not a task-oriented system. What Kubernetes gives you is a declarative approach to deploying your applications and infrastructure. And there is a concept called desired state model. So as an operator, as a developer, you express the state of your application, the specification of your application, how you would like to run it in production, and you hand this over, this manifest, this desired state, to the Kubernetes cluster, and it will make sure that at any given time, the actual state in the running cluster is matching the desired state that you have specified. And this is why this is a declarative approach. It's very much in line with modern GitOps approach to managing your infrastructures and applications. So the impact of having this Kubernetes as your application platform, one of the impacts is that we are able to create what we call loops, inner loops and outer loops, right? So in the inner loop, you can see that you have a developer who is creating an application, writing application source code. He or she is then able to basically deploy this into a Kubernetes cluster. They can define their service level objectives. They have a very consistent and repeatable path to deployment of this application. And this is going to happen on, you can think of these as developer sandboxes. You can think of these as developer clusters, etc. Once this is done, your automated pipelines will allow your operators to shift this application into a production environment, a production cluster. And here you have, more security controls, you have more governance, you have quota management, you have security enforcement, and you have many different tools to manage and monitor and provide observability metrics about your infrastructure and applications. So closing the loop between the Kubernetes operators, the application developer, and security folks, this is what this platform delivers to you. So an end-to-end seamless way of delivering applications from the developer sandbox all the way to production clusters. So what does Tanzu Kubernetes bring? Now let's discuss a little bit about, we discussed the high-level Kubernetes overview and microservices. So let's look at Tanzu Kubernetes. So the Tanzu portfolio is basically divided into 3 pillars. If you look at, building modern applications and then running them in production, there are 3 major categories. The first is focused exclusively for people who are writing source code, who are building these modern applications. And we call this the build pillar. The next is the run pillar, and this is focused on the Kubernetes and Kubernetes distribution itself across different clouds and for architectures. And then we have the management, the monitoring, the observability of these applications and infrastructure. So if you zoom in on this a little bit, you will see that, in each of these pillars, there are a number of different products and services. So for example, the build pillar has Spring Framework. If you're doing Java development, if you're doing .NET development, .NET Core, ASP.NET or .NET 5 development, then you have steel toe frameworks here. But more importantly, you have some tools here which allow the DevSecOps teams to automate the whole process of building container images from source code, and then putting them into and deploying them on Kubernetes cluster. So this is where Tanzu Build Service comes. Not today, but maybe in another session, we can deep dive into these components individually and show you the benefits. But in a nutshell, Tanzu Build Service is a more comprehensive, more advanced, more automated way of building container images when compared to Docker Build and Docker Compose. Tanzu Application Catalog is a repository of upstream projects, open source projects. And essentially, when you are building these cloud native applications, you will be depending a lot on upstream OSS projects. So you'll need, for example, Apache Web Server, you might need MongoDB, you might need MySQL. So where do you fetch them? And how can you be sure that the image that you're deploying in your cluster is secure, is validated, is signed? And this is what Tanzu Application Catalog brings you. It brings you a repository of upstream open source software, which is secure, which is signed by VMware, all the images. But more importantly, it also allows you to build your custom images. And we will provide the lifecycle management for those applications. So you can supply your own base operating system image, and then you can choose the application you want from the upstream projects. And then we will provide the lifecycle management, continuous updates for that application. We have Tanzu Data Services. It's a huge portfolio of databases such as Postgres, MySQL, in-memory database such as Jamfire, and we have a big data solution called Greenplum. These are including RabbitMQ. So these all fall under Tanzu Data Services. And then finally, we have in the build pillar, we have Tanzu App Platform. And Tanzu App Platform is our new application platform, which offers you a complete automation from source code all the way to a running application in a production Kubernetes cluster. It is what we call an opinionated platform. It comes with very strong default configuration values. So as a software developer, if I don't want to configure individual components myself, such as networking, routing, ingress controllers, if I don't want to define all of these manually myself, and I only want to supply the platform my application code, then it will take that application source code, build the container image for me, deploy it on a Kubernetes cluster, deploy the load balancers for me, deploy the ingress controllers for me, and give me a URL to access this application at the other end. It's a completely automated platform. The reason we have this is because when we build modern applications, there are essentially two paths that developers can take. One is a highly automated way of building applications where you do not really want to get involved in provisioning underlying components for your application. The other is, a more manual way, a less opinionated way, where you get to define individual components for your application and how you're going to run this in production. Both of these are possible with Tanzu Portfolio. Now, on the run side, we have Tanzu Kubernetes Grid. This is what we will focus on a bit more in detail later on. This can run on vSphere. It can run on VMware Cloud Foundation, VMware Cloud and Amazon, and any of the public clouds out there, including your edge locations. We have a management pillar here. In management pillar, we have observability. We have service mesh, which is based on Strio, and we have mission control. Observability is basically a time series data and analytics tool. And as a service, as a SaaS service, it is capable of ingesting millions of data points of any specific metric that you are interested in from the application. And it can monitor the application specific metric all the way down to infrastructure metrics. And it can report on latency, P90, P99 factors, and report where there could be possible reason for slowness in response, etc. It has many integrations as well with most of the common applications out there. We have Service Mesh, which is based on Strio, but it offers you some additional capabilities. So we have the concept of a global namespace. So in a nutshell, what you can do is you can take your application microservices running in different clouds and different clusters, and you can tie them together. So you could possibly, for example, an extreme example of this would be that you're running one microservice in your Amazon cloud, another one in Asia, and the backend database is sitting on your on-premise data center in Riyadh. You can have Tanzu Service Mesh connect all these microservices together and run your application. Now, this is an extreme example. In reality, you may not do that, but it just goes to show what you can do at a layer 7 networking level without rewiring or doing any of the networking at layer 2, layer 3, etc. By simply using the Tanzu Service Mesh, the concept of global namespaces, you can distribute your application across the world, if you like, really. And we have demonstrated this very successfully using the Service Mesh technology. It also, of course, provides you advanced capabilities such as encryption. So all communication between microservices, regardless of the cloud architecture, is going to be encrypted. So service to service, user to service, and then service to backend data, all the communication is fully encrypted as well. We have Tanzu Mission Control, and Tanzu Mission Control gives you a single pane of glass where you can monitor all your different Kubernetes clusters. And when I say different Kubernetes clusters, what I'm really talking about is you could have Tanzu Kubernetes Grid in one cluster, you could have OpenShift in the next one, you could have EKS from Amazon, AKS from Asia, you could have upstream open source Kubernetes, and you can manage, you can monitor, you can provide control and governance, quota management, just lifecycle management across these different types of Kubernetes distributions from Tanzu Mission Control. Now, this is, of course, for customers who have different types of distributions running in their data center and also making use of managed services such as AKS and EKS. So this was a quick overview of the Tanzu portfolio. In today's session, we are going to look more deeply or in more detail at TKG, Tanzu Kubernetes Grid. But I'm sure that in subsequent sessions, we'll come back and revisit the build pillar and the manage pillar and go into these products in more detail. So the first step is to standardize on a Kubernetes platform, to manage, to monitor, to secure the containers across any kind of cloud or any kind of cluster. This is the first step for us to build this modern applications platform. When it comes to Tanzu Kubernetes Grid, there essentially, there are two ways, or think of them as really two flavors of deploying your Kubernetes on your vSphere platform. So you have, one option, for example, one option is to have Tanzu Kubernetes Grid running on, let's say, vSphere 6.7. If this is your, your hypervisor, it's a multi-cloud solution where you can run this on VMware Cloud on Amazon. You can run it on native EC2 instances in AWS, native on Azure as well. This is one particular way of deploying Kubernetes, Tanzu Kubernetes Grid. The other is more innovative. It's a brand new concept. This is vSphere with Tanzu, and this is applicable only to vSphere 7. And the reason is because we have introduced a number of new concepts for our customers who are running vSphere 7, and a number of new additional capabilities and how they deploy and interact with these clusters and how they do lifecycle management, and also how the developer and application teams can access these Kubernetes clusters. So the two primary use cases here, depending on where you want to deploy your Kubernetes clusters, you can go for one of them or both of them if you happen to have both type of environments available for in your organization. So before I go into the details of vSphere with Tanzu, the Kubernetes inside Tanzu Kubernetes Grid distribution, I want to talk about that a little bit. So inside Tanzu Kubernetes Grid, we have what we call the upstream cloud native computing foundation compliant distribution of Kubernetes. In other words, we have a pure vanilla Kubernetes, which we do not modify at all. So it's 100% compliant with CNCF, or the release that comes out of CNCF. That's the first thing, right? When it comes to common services that you would expect from any Kubernetes clusters, authentication, monitoring, logging, etc., we have a number of open source projects that we provide as part of the solution. A lot of these open source projects originated inside VMware in our R&D labs. We then later on open source these. So a famous example of this is Hardware Registry. This is one of the few graduated projects of Cloud Native Computing Foundation. I'll talk a little bit more about this later on. We have Alero, which is a backup and recovery solution for your Kubernetes clusters and all the workloads and applications which are running in Kubernetes. Octant, a modern interface which has the plugin concept. So you can monitor your Kubernetes clusters, all the workloads that you have running inside these, and also do some sort of management on those workloads. Sonaboy for conformance and compliance. If you want, for example, to benchmark your Kubernetes cluster against another, for example, security benchmark such as CIS. If you want to do any kind of benchmarking, configuration benchmarking, then you can use Sonaboy for conformance. We have Antria, which is our CNI, our default container network interface in Tanzu Kubernetes Grid. And this is, again, it was created in VMware, and then it was later on open sourced. Apart from this, we support other open source projects as well. So we provide them, we support them, such as Grafana, very common visualization tool, very popular as well. Prometheus, FluentBit, Calico, another CNI we support, Contour for ingress, and then Cluster API. Now, Cluster API is extremely important for us, and I'll talk more about this in a bit. So this is what's running inside Tanzu Kubernetes Grid distribution. So at a very high level, if you look at Tanzu Kubernetes Grid, this is what we have. We have different types of architectures here, different types of cloud, and then we have a consistent, Tanzu Kubernetes Grid cluster offering on top of these. What is abstracting, these cloud providers and architectures is Cluster API. Cluster API has basically a provider for each of these different hyperscalers, and obviously for vSphere as well. This helps us in abstracting the Tanzu Kubernetes grid from underlying infrastructures. So let me explain a little bit more about Cluster API. So Cluster API is basically a project of the special interest group in CNCF, which is focused on cluster lifecycle, Kubernetes cluster lifecycle. And essentially what Cluster API brings to the lifecycle of Kubernetes clusters is a concept of declarative approach to bootstrapping, to provisioning your clusters, right? Kubernetes clusters. Think of this as, the same way that Kubernetes can manage the state of an application, the desired state of an application declaratively. Cluster API provides the same capabilities to create, to provision, to bootstrap Kubernetes clusters. So essentially, a declarative desired state model for the Kubernetes clusters. This is a huge shift from the past, because in the past you had proprietary mechanisms. Different vendors were providing their own tools. They were providing their own ways of provisioning Kubernetes clusters and doing lifecycle management. There was no consistency across any of these different vendors. So this is why there was a need to have some consensus on how you're going to provision Kubernetes clusters and provide lifecycle management. This is, again, become a success. As you can see, there is all the major, cloud vendors out there have providers for Cluster API now. All the big logos are there, and all the big logos are there in terms of community participation as well. So it's going to be the next default, way of providing cluster lifecycle management. How does Cluster API work? This basically works on the same concept that we use in Kubernetes. So your user supplies the definition or the specification of a cluster using a manifest file, which I'll show you later on, hands it over to the Kubernetes management cluster. It then can go and deploy and provision these Kubernetes clusters on different types of cloud architectures. So whether it's on AWS, native, Google Cloud, VMware running on vSphere, Azure, it's going to be consistent across all of them, right? And it's going to do the lifecycle management of these Kubernetes clusters. So how does it actually work underneath? How has it been implemented? So just like you have a pod in Kubernetes, you have some new abstractions which were introduced in Cluster API. So machine is one of them. You have a replica set in Kubernetes. In Cluster API, you have a machine set. You have a deployment in Kubernetes, and you have a machine deployment in Cluster API. So basically some new resource types and new objects were introduced in Cluster API. And then what this allows operators to do is to manage and run their Kubernetes clusters exactly as they would manage an application running on a Kubernetes cluster. I'm just going to pause for a second, Abdulaziz, or anybody, if there's a question that I should address or answer.
I think there is one question, I think, in the Q&A.
Yeah.
Muhammad Hijazi is asking, did you try to add SharePoint farm in Tanzu?
A SharePoint farm in Tanzu? Did I try? No, we did not try. What we have tried is basically we have tried deploying ASP.NET applications. We have deployed .NET Core applications on Tanzu, which worked fine. We have not deployed SharePoint on a Tanzu Kubernetes cluster. We just to let you know, we do have an experimental support for Windows worker nodes right now, which is going to be GA at some point in near future. And I assume that once we have Windows worker nodes as part of the Kubernetes cluster, then this would be something that we could possibly do. I don't know if I've answered your question, Muhammad, but let us know. If not, then please. So I think there's another question here. It says, is .NET traditional applications supported to run within Tanzu. So .NET traditional application is not, however, .NET Core is. So if you're going to run an application on, and this is not just for Tanzu Kubernetes Grid that I speak of, I'm just speaking in general here, that if you are going to run a .NET application on a Kubernetes cluster, which has Linux worker nodes, then it has to be a .NET Core application. That is supported on Kubernetes clusters running with Linux worker nodes. If you're going to run traditional applications which are not .NET Core, not .NET 5, you would need a Windows worker node. And this is not there today. Okay, so it's experimental right now. We have tested it, works, but it's not GA generally available at present. There is another question here about, I think it was where Pivotal Cloud Foundry fit in VMware Tanzu. So Pivotal Cloud Foundry is, I'll answer this briefly in the interest of time. Pivotal Cloud Foundry is now called Tanzu Application Service. So it has been renamed Tanzu TAS, Tanzu Application Service. Tanzu Application Service, if you know Pivotal Cloud Foundry, you will know that it doesn't run on a Kubernetes cluster. It runs essentially on a bunch of virtual machines. So it provisions virtual machines and it then runs applications in those virtual machines. What we still have that offering. It is part of Tanzu portfolio. If a customer is not necessarily interested in the Kubernetes platform and is only looking for an application automation, end-to-end automation of application delivery from source code to a running application, then Pivotal Cloud Foundry or Tanzu Application Service is still available to you as a solution. However, we have a new platform, which I was describing earlier, Tanzu Application Platform. And Tanzu Application Platform is going to be generally available very soon. It's in beta at present. This allows you to basically do the same thing that Cloud Foundry did, which is to provide your source code, and it will give you a running instance application on a Kubernetes cluster. And we will provide the CF push interface, this Cloud Foundry interface with Tanzu Application Platform. So you would have CF push experience that you have from Cloud Foundry, okay? So there is another question here. It's about backup, I think. Should I take these questions at the end, Abdulaziz, do you think, or should I answer them as?
Yes, much better. Let's postpone this question until the end of the session. Then we can answer all the questions.
Outstanding questions.
All the attendees. Yeah.
There are a few questions. I will. I think Karam is going to type some answers, but I'll address the outstanding ones later on at the end. So basically, this is coming back to Cluster API. This is what it offers. So if you look at vSphere 7 with Tanzu Kubernetes Grid, what we are really doing is we are basically allowing your application developer or application operator, people who are responsible for the deployment of applications, giving them access to this platform. This is the new concept. So on the one hand, you have the vSphere administrator. Many of you would recognize this persona. They were accessing the vSphere clusters using the vSphere web client, provisioning virtual machines and networks and storage, and then giving developers access to those in which they would then deploy their applications. In the new scheme of things, we are exposing the Kubernetes API directly to this persona here. We call it at a very high level, this persona is an operator, but essentially this is an application operator, application owner, who can access the Kubernetes API directly from the vSphere platform and then do a number of things, right? These number of things are basically, for example, create a Kubernetes cluster on demand, create a virtual machine using Kubernetes manifest files, deploying a Kubernetes pod on the ESXi servers. That's one of the new features. So this is what we offer as part of vSphere with Tanzu, and this is the new concept. There is one instance of this where you have, vSphere only without NSX. So you have vSphere, vSAN, and your typical, vSphere networking distributed switch here. So you have Tanzu Kubernetes grid running here. We will provide all the networking, load balancing, ingress controllers as part of the solution. And then you can run a variety of different applications on top of this, including existing monolithic applications as well as more modern cloud native applications. We have the VM service, as I was just saying. We have the network service, all the networking. We have the storage services. So basically the repository where you have, your container images. So Harbor registry here. If you happen to have NSX in your environment, if you have vCloud Foundation, for example, then you will get a few other capabilities. One of them would be a built-in registry, which is embedded in as a Kubernetes cluster. The other thing you would get is this ability to deploy vSphere pod. This is a new concept, did not exist before. This is a Kubernetes pod running directly on the ESXi server, right? And this has some specific use cases which you can use. What you get at the end of this, once you have vSphere 7 with Kubernetes, is that you have some new concepts here. We have a concept of a namespace. This is not a Kubernetes namespace. This is a vSphere namespace. It is visible inside the vSphere web client. And what this allows you to do is to basically club your different, your different components of your application into one logical unit. So you have the concept of a vApp and a resource pool, and we capture this inside a namespace. Once you have done this, you can then enable, you can decide who gets to access this namespace, which means who can, access it and deploy a Kubernetes cluster, or deploy an application, or deploy a virtual machine, what kind of permissions they have. We can do persistent volumes for your Kubernetes cluster. So which kind of storage they come from, what type of storage you want to allocate to this particular namespace, how much capacity and utilization will you allow to this team. So you can put some limits here, some quota on CPU, memory, and storage. So these kind of things. So you can apply these governance, these policies at a namespace level, and your Kubernetes clusters, applications, VMs are all part of this namespace, right? Apart from this, you have the supervisor control plane. I'll come back to this later on when I go to my demo. So logically speaking, you have your a modern application could be composed of 3 or 4 different types of applications. So you have your modern Kubernetes cluster, which is running your containerized applications. You have a serverless architecture here, serverless, which basically means maybe Knative, or you have some pods running directly on the ESXi server. You have some services running in virtual machines. You have databases running in virtual machines. So this could possibly be one of the applications. It's not all modern. It's not all monolithic and old school. Maybe it's a mix. So front end is modern, the back end is still in databases. So when you have this type of architecture for your applications, with vSphere 7 Kubernetes, we are going to allow you to use the Kubernetes manifest files, the desired state declarative approach to building these Kubernetes clusters, to deploying this pod on ESXi servers, to basically creating a virtual machine in the same way by providing a specification using the Kubernetes manifest, and in the near future also deploy common applications. One example could be, for example, HANA database. We are working with our partners, all the big vendors such as SAP and Microsoft and Oracle, etc. We're going to come up with these type of specifications where the application operator can directly deploy a database or an application on a Kubernetes cluster by using the manifest files. So this is what we anticipate when it comes to an application operator. We anticipate that this is the type of applications they will be deploying on the Kubernetes cluster. Architecturally, this is built on software-defined data center. So you're all familiar with that. I think the vSphere hypervisor, NSX, vSAN. NSX is obviously not essential for Kubernetes or Tanzu Kubernetes Grid, but if you have it, there are some additional capabilities here. So we have a concept of supervisor cluster. Supervisor cluster is your primary Kubernetes cluster on vSphere platform. And you can have enable these on 3 nodes or 4 nodes or more. And then you can have as many as you like, depending on your use cases. Once you have done this, you enable with the right license keys, you have vSphere with Tanzu services enabled in this. You can then create namespaces, which I was just describing to you, which are basically your resource pools. And from that point onwards, you can allow your developers to go and create the Kubernetes clusters on demand for their applications. This is at a very, very high level. Once they create these Kubernetes clusters, they can then deploy their applications inside these Kubernetes clusters. They can create their own namespaces, as many as they like. They can deploy their applications, and all the networking around this will be provided automatically on demand. If you zoom in a little bit, then you will see that the way we bootstrap these clusters is basically, you are running your virtual machine here, or basically a Tanzu Kubernetes Grid CLI or user interface. You enable the supervisor cluster here. Once the supervisor cluster is enabled, you can then create or allow your developers and operators to create as many Kubernetes clusters as they like. One of the new things that we introduce here is vSphere Pod, and vSphere Pod is running directly on the vSphere ESXi servers here. We introduced the concept of CRX, which is container runtime extension, running directly inside the ESXi server. It has a small Linux kernel, Photon operating system. It provides a container engine, and then you can run your container images on ESXi. And I'll show you an example of this in a little bit. So from the perspective of different personas, we think that the VI admins are going to be responsible for creating the namespace, the governance, the control, the quota management, etc., all of those policies. And then once that is done, the DevOps teams will be responsible for deploying the applications, whether they are Kubernetes pods or virtual machines, or maybe they're just pure virtual machine-based applications, or even a cluster or many clusters on demand. So this is the model that we see our customers adopting, one of the 3 or maybe a combination of this. We have enabled these services by introducing some operators. So for example, when you provision a VM using a Kubernetes manifest file, we have introduced VM operator here. For the cluster provisioning, we have cluster API, which I was talking about earlier on. We have also, Tanzu Kubernetes Grid guest clusters here. This is a concept, where, for example, your developer wants to create a developer sandbox, maybe a 1 node or 2 node small machine cluster, with one control plane machine, just to build their application and test it. So here we provide them the self-service experience of being able to access the vSphere platform and of being able to create a cluster on demand inside this namespace. So at a very high level, it then looks like this. You have your, step 1, you create your Tanzu Kubernetes cluster. Step 2, you use the common kubectl command line, which is, if you are managing a Kubernetes cluster, then you would know this kubectl syntax. You will use this and the manifest file to create your Kubernetes clusters. The definition of the Kubernetes cluster is basically a specification inside a manifest file. It just tells you how many control plane nodes you need, how many worker nodes you need, what kind of profile of the worker node in terms of CPU, memory, etc. Something about the CNI, and that's it. And it will go ahead and create the cluster for you. This cluster is, of course, going to be upstream Kubernetes. It's going to be fully compliant with CNCF Foundation, and it will then be maintained just as Kubernetes maintains applications. We will maintain the state of the cluster, meaning that it will reconcile from any failure, so hardware failure or failure of an application or worker node, etc., will be automatically reconciled. This is what a manifest file looks like. I was just describing it to you. You can see that this is, very similar to your regular, any manifest file that you would create for an application. The only difference is that we have introduced some new kinds here. So this is a Tanzu Kubernetes cluster kind. We have a name of the cluster, the namespace in which you are going to create this. We have a control plane. So this is basically the Kubernetes master node. Because this is a developer machine, we don't need 3. We can just go ahead and create 1. We have 3 worker nodes, the version of Kubernetes that you want to deploy, in this case, 119, the type of storage you want to create here. So it depends on how many storage classes you have defined, and we will automatically, create your persistent volumes in the storage that is provided in the vSphere platform. So this allows you to create the cluster. It also allows you to scale out your cluster. It allows you to update your cluster by simply modifying this file. So for example, if you wanted to upgrade this Kubernetes cluster from 119 to 120.2, then all you need to do is just, update the version here and apply this new file. It will go ahead and upgrade the cluster for you. And because Kubernetes is based on the concept of immutable infrastructure, you are not doing in-place upgrades. So you're not upgrading existing worker nodes and master nodes. What you do is you deploy a fresh master node, a fresh worker node with a new version, and you take the old one out of service. So this is also one of the concepts in Kubernetes, which is of immutable infrastructure. Container registry, obviously, I spoke about this earlier on. We provide this as part of Tanzu Kubernetes Grid. It has a number of great features. So I'll just highlight some of them. First of all, it can store, apart from container images, it can store any kind of OCI compatible format. So you're looking at, Helm charts, for example, CNAPs, Cloud Native Application Bundles here. If you have OPA policies, then you can store those here. Singularity, anything that is OCI compatible can be stored inside the Harbor registry. The other great feature of this is the scanning for malicious code and viruses. So you, by default, we supply Trivy as a scanner, but we also have an interface where you can go and change and use other multiple scanners to monitor or to scan your container images here. We also have some advanced features in the registry. So for example, if you have an insecure or vulnerable image, you can actually stop the Kubernetes clusters from pulling that image and deploying that onto the cluster. We can put some quotas on it. So depending on the teams, you can put a project quota so they don't end up using all your storage for the images. We have replication capabilities in this registry, so you can see, which is pretty much a very comprehensive list from Harbor to other registries. Quay, for example, from Red Hat, Google GCR, AWS ECR, Azure ACI, quite a comprehensive list. So you can actually replicate your registry and the images from Harbor to another one. In terms of networking, at a very high level, we have 3 different things to think about. We need a software-defined networking for Kubernetes, so the CNI. Kubernetes networking is basically inside the cluster. All the networking that happens from pod to pod is all east-west traffic, and that's not visible outside the Kubernetes cluster. It's not routable, right? It's not routable. These are not routable pods. So this is basically container network interface managed by CNI, and we provide Entria for this. We also support some other CNIs such as Calico and Multus. Layer 4 is basically load balancing services. We provide this out of the box with Tanzu Kubernetes Grid, and we have layer 7, which is the ingress controller. So basically path-based routing, HTTP, HTTPS-based routing for your application. All of these are part of Tanzu Kubernetes Grid solution out of the box. In terms of Entria, at a very high level, it's an open source solution. It was built in VMware, it was later open sourced so that the wider community can also make use of it. It's based on OVS, Open vSwitch, as its data plane. And we also support, as I said before, we also support Calico. In terms of load balancing, you can define service type ingress in your Kubernetes manifest. You can define service type load balancer. in your manifest, and the Kubernetes platform running on vSphere will automatically deploy the relevant type of service at the back end. So layer 4 load balancer or ingress controller for you. We will take this, Kubernetes API object, which is services or ingress type, and then convert that to a load balancer automatically or ingress controller at the back end, and then create the policies for those. For the master node, which is running the Kubernetes API and etcd, we automatically provide a load balancer. So for across these three different, if you have three different control plane nodes, a load balancer is automatically provisioned for you. For the workloads, as I said before, this is up to the application operator, what type of load balancer or what kind, if they need a load balancer ingress, all they need to do is define this type here, and it will be provisioned by the infrastructure. For ingress at layer 7, we support obviously all the OSS projects out there for ingress, but our own solution for this is Contour. Again, it's an open source project, but it's part of VMware portfolio. This is depending on Envoy technology, Envoy sidecar container technology for data plane, and the ingress controller is Contour here. So we are taking, it allows the software developers to define different URLs to the application, different types of services running at the back end. So you define different types of paths here, and the Contour controller, ingress controller, along with the Envoy, will route the traffic to the right service at the back end inside the Kubernetes cluster. In terms of mission control, Tanzu mission control, the global, the single pane of glass, we have two different types of clusters that we can manage from Tanzu mission control. The first is what we call, where we do lifecycle management. So these are clusters that have been provisioned from within Tanzu mission control. So you can actually create a cluster on vSphere. You can create a cluster on AWS. You can create a Kubernetes, Tanzu Kubernetes Grid cluster on Azure natively. The others are what we call managed. And here we are basically attaching an existing Kubernetes cluster to Tanzu mission control. So these are essentially two types of clusters that we have here. This includes EKS, GKE, or any upstream Kubernetes here. Once you have these clusters under the control of Tanzu mission control, you can then do a number of things here. So for example, you can provide identity and access management. You can provide security for your registry. You can have network policies. You have security policies for your image registry. You can do quota management, and you can even create custom policies that you can apply uniformly on all the Kubernetes clusters which are running in the different cloud providers. So you have different types of organizations here. You have, for example, a concept of cluster groups and workspaces, which basically means that, let me show you a concept of cluster groups and workspaces here. So what you can do is you can take your clusters from different cloud providers. So you could possibly have a cluster sitting inside AWS native. You could have a cluster running on vSphere, a Kubernetes cluster running on vSphere, and you can put them in a single cluster group. And once you have put them in a single cluster group, you can control access policies, image registry policies, network policies. And when you implement those policies, it will get deployed across these different clusters. So for example, if you want to allow a certain team of, certain individuals access to a cluster group, you just need to create this policy, give them access to this cluster group, and they will have the same policy implemented individually inside these clusters, regardless of where they are. The same logic applies to workspaces. It's the high-level abstraction of namespaces. So you can take a namespace from a vSphere-based Kubernetes cluster, one from AWS-based Kubernetes cluster, put them in the same workspace, apply your policies. So it's a very, very powerful way of organizing and deploying and implementing your policies. We have also got I think I spoke about this earlier as well, but we have these extensions. These are signed images of all these, common projects, open source projects. These are, you basically download these and you apply them as you would apply any other Kubernetes application. So we have log forwarding here, we have ingress controllers, alerting, monitoring, etc. So just an example of FluentBit, for example, it deploys a daemon set, and then you can have this, FluentBit forward its logs to a log collection service. One example of this is obviously vRealize Log Insight. Many customers are using vRealize Log Insight. And if you have this in your organization, you can have the FluentBit forward all the logs to vRealize Log Insight. If not, then you can also obviously create, another cluster. You can deploy things like Elasticsearch or Splunk or Kafka or something, and you can then have your logs forwarded to that service as well. Same goes for Prometheus Grafana. It's a very popular combination of for monitoring and visualization. So Prometheus is kind of responsible for collecting all the data and all the metrics and alerts and for notification. And then Grafana is responsible for creating these, dashboards for you, visual dashboards for you. These are just some examples of how you can take, common open source projects, signed images, deploy them in Tanzu Kubernetes Grid, and these will be fully supported. These are fully supported by VMware. So in a nutshell, then, everything I've been describing so far, it kind of helps our customers build this modern application supply chain. Our focus today has been mostly on Tanzu Kubernetes grid clusters themselves on VCS 7, right? But you can see that this is one important concept here, one important technology here, and the way we deploy this on VCS 7 with the way we do lifecycle management, the way we do upgrades, updates on this is fully in line with the GitOps approach or infrastructure as code approach here. We have the operator persona here responsible for deploying these clusters, but at the same time, we have a developer persona here. And developer persona is basically writing the applications. We are providing them all the different tools here to be able to pull their, build their application into container images, store them in a repository, a registry, container registry, to pull from there and deploy them inside different types of clusters, developer sandboxes, staging, production, pre-production, etc. And these are basically managed by the continuous delivery pipelines here. We have supporting services for monitoring, observability, cluster management, and upstream catalog of upstream projects, open source projects. We will come back, at a later stage and, go into detail about Tanzu application platform, the build service, more details on catalog, mission control, observability. But I think that will be another session. In terms of any questions that I should answer?
I think we passed the time. Already?
Okay.
Yes. Yeah.
So let me just quickly show how. Should we end now, or should we continue a little bit longer? What do you think?
Maybe if just like 5 minutes, then we can have another 5 minutes for Q&As.
Okay. So I will just point you to some, obviously we will share these slides with you, so you will have the links to the hands-on labs for Tanzu Kubernetes Grid running on vSphere. So you can run all these labs. Each lab is about 90 minutes, roughly. You can really have a hands-on on different products in the Tanzu portfolio to get a feel of what it looks like, how it works. We have something called Modern Apps Ninja. This is a great way of learning Tanzu Kubernetes Grid and some of the other products in the portfolio. This is modernapps.ninja. This is the website. We have cube.academy. This is a great way to learn Kubernetes and all things related to Kubernetes, so networking, storage, CNIs, etc. Not necessarily Tanzu Kubernetes Grid, but Kubernetes Grid in general. So OSS here. All of these courses are free. You just need to enroll, and you can then start and run these courses. We have a Tanzu Developer Center for those of you who are developing Java applications, .NET applications, Python, Golang, a huge repository of information about and sample applications, and also some many live workshops, so 15 to 20-minute workshops where you can deploy applications in Java on Kubernetes clusters, play with serverless architecture such as Knative, etc. Run some pipelines, for example, Argo CD or Contour or Concourse, sorry. So you have a number of different labs here that you can play with. I will, one thing I didn't say at the beginning was our involvement in the Kubernetes community is quite deep, because two of the creators of Kubernetes or founders of Kubernetes and CNCF are actually, working at VMware. They are the people behind Tanzu Kubernetes Grid. So Craig McLucky runs our R&D for Tanzu. Joe Beda is the principal engineer for Tanzu Kubernetes Grid. One other great news for you, all of you, is that we have just announced the Tanzu Kubernetes Grid Community Edition, and this is 100% open source, free of charge Kubernetes offering from VMware. So what you can do is you can go to tanzucommunityedition.io, download Tanzu Kubernetes Grid, and you can run it on your Mac laptop. You can run it on your Linux machines. You can run it. There is no restriction in the features. There is no restriction in the capabilities of Tanzu Kubernetes Grid Community Edition. The other advantage that you will see here is that we will introduce all the new features and functions inside Tanzu Community Edition first, before they make it into our commercial releases, so commercial offering. Okay, so questions? I didn't have a time to run through my demo, unfortunately, but
yes, I think there is a question here, Zahur.
Yeah.
It's from Anis Sheikh.
Yes, we have Tanzu Kubernetes with Azure, as I'm trying to take backup from TMC UI, but while I take backup in S3, it will fail. But okay, maybe you want to give him the option to speak, because I cannot fully understand.
Okay, let me check if Anis is here, and
they have not left. Okay.
Yeah, he's there, Anis Sheikh.
Hey, hi.
Hi, Anis.
Hi. Actually, my question is simple. Like, when we take the backup from the TMC,
yeah,
which is Tanzu Mission Control. So when we skip the volumes, so that time it will take backup successfully. But while we keep our volumes, like persistent volumes or PVC, so that time our backup is failed with the error.
What on Azure?
Yeah, on TMC. On TMC, we take the.
Where is your cluster? Is it in Azure or vSphere?
Azure.
Azure. Okay.
Yeah.
The persistent volume is not backing up. Okay, I think we need to take this offline, because I don't know the answer up front. We need to investigate a little bit why you cannot back up, because if I run the backup, I can do it, it seems, without any issues. So we need to obviously look at the reason why this is not the case here. In my case, it seems to work fine without any issues.
Okay. Because currently we have Azure as for Azure, we have successfully take a backup for our 2-3 services, like shared service cluster or stage cluster. But while I will take the backup for AWS, so it will fail. Like We are using AWS as well. There are 2 clusters over there, different clusters. Both.
Okay. If you don't mind, if you can just drop us a line, maybe I can host and panelist. I can do it to everyone. I can put my email address here in the chat window so you can see it. You can reach out to me and I will connect you with the right people and obviously the rest of the team here we'll investigate this further for sure.
Okay. Because I also create like support requests for VMware for that, but they will also don't understand.
Okay, fine. I mean, I'm happy to take a look at it. I have no problems. I mean, we can explore this between myself and Salah. We can have a look and discuss it.
Yeah, definitely. Thanks for your help.
You any other questions, Abdulaziz, that I need to answer?
Actually, I also face like some issues regarding machine deployments. I don't understand the behavior of machine deployment because from our running production, there are 2 nodes are missing. Well, I check the machine deployment status over there, so it will down the replica from 2 to 0. So
you deployed it from TMC? Is it deployed from TMC or deployed from management? How did you deploy this?
Actually, we deployed using the Tanzu CLI. Basically, for Azure, there is many manual intervention as per the Tanzu document for the Azure. So we created all the steps using the Tanzu CLI from our bastioners.
Okay, fine. So we will take a look at or troubleshoot it with you, I guess. I cannot offer you a solution, unfortunately, as much as I would love to. I don't know. I need to look into this with you. So
yeah, understood. Because
connect with me. Yeah, make sure please connect with me, and I will work with you and with Salah, obviously, to explore this further. We have some question from us. A question from Osama. It says the master workload is on the hypervisor, and the workers are on VMs or what? Okay, so basically, let me show my interface. It's about time. You know, I didn't get a chance to do the demo, but this is what it looks like. We have a vSphere 7 user interface here. These are my physical servers. So you can see ESXi 1, 2, 3, and 4. Once you have the right license keys, you enable workload management here. You will see that you have something called supervisor control plane VMs. These are virtual machines created on these ESXi servers, Osama. And we have 3 of them running. So they are in high availability mode. We have DRS enabled, HA enabled on this cluster. These are managed by the vSphere platform. So if I right click on these, you will see that I cannot do anything to this. I cannot power on, off, suspend, or anything to these VMs. These are fully lifecycle managed by the vSphere platform. We have the namespaces here, and the namespaces can have an application. These are Kubernetes pods running natively. It's an application, a user interface, a backend database, and something else, a Redis cache. And then you can have a cluster inside these. So you can have multiple clusters inside a namespace. So I have a Kubernetes cluster, and these Kubernetes cluster is again a bunch of virtual machines basically. So this is a control plane VM. This is a virtual machine, and you have 4 worker nodes, which are also virtual machines here. But just like the supervisor VMs, you will see that you cannot do lifecycle management here of these VMs as you would for normal virtual machines. So you can't create them here. You cannot, do vMotion, things like power on, off, suspend, etc. Right? So anything inside a Kubernetes, this namespace, vSphere namespace, is fully lifecycle managed by the vSphere platform. And this is kind of the new thing in vSphere 7 with Kubernetes. Okay, I hope I answered your question. So yes, the answer is they are VMs running on the ESXi server. These pods these Kubernetes pods are running on the ESXi server here. So these are deployed directly on the ESXi servers. If I click on this pod, you can even see, for example, you can see, which node it is running on. So you can see this is running on node number 2. And I have, of course, more visibility here. I can look at the performance of this particular application, deeper view. But this is a Kubernetes pod, a container running on the ESXi servers. I hope I answered your question. If not, then please let me know. Yeah, so will there be a demo for developer experience? I think we need to schedule another session in which we will walk you through the developer experience on this platform. So we can show you how you can create an application and then deploy it, and how you can provide other services from a developer perspective. So the user interface, application, the container build process, deploying and pulling images from the registry using open source images, and then ultimately pushing them on a Kubernetes and building CI/CD pipelines. So yes, there has to be another session focused on the developer experience side of things. If we have.
Is there any other questions? I think there's one more question from Osama. Would you please clarify this again, the master workload?
Yeah, so this is what I was just answering. So the master workload, master machines are virtual machines which are running on these ESXi nodes. So yes, the answer is yes.
Okay.
He said okay.
Okay. If there is, yeah, please.
I was just going to say, if people want to stay for a few more minutes, I have a video of the deployment of these clusters, because it takes like 30 minutes in my lab. So I created a fast forwarded video to show them how it looks like when you deploy it from scratch.
Okay, if it is okay with you guys, just mention in the chat that it's okay with you, so we can go ahead and show you the video of the demo. I think, yeah, okay. I think you can. There is some attendees who's interested.
Okay.
Zahur, so just please go ahead.
Sure. Let me just pull up my slide here. Because it takes 30-40 minutes in my lab, I thought it would be better if I just create a step-by-step video. So this is vSphere 7 with Kubernetes. So the first thing you do on vSphere 7 platform, when you put the right license keys, is enable Kubernetes on it, right? So right now you can see this is a blank server. There is no Kubernetes on it. So I'm going to play the video and I'm going to fast forward it a little bit to save time. So here you go, you have something called the workload management. If you click on the workload management, you will see that it will give you a visit at the very beginning. All you need to do is basically enable, run this wizard, select your cluster. So I have 4 nodes in my cluster. I will select that and I will hit next. I will select the size of my control plane virtual machines. So I'm going to pause it for a second and show you what this means. A small means that I can run 1,000 containers, 1,000 Kubernetes pods on it. So it takes about 2 CPUs and 16 GB of storage and 8 GB of memory. So this is the control plane or Kubernetes master nodes VM size. You have small, medium, and large as well. So if you're planning to run a large number of Kubernetes pods, you can select a bigger control plane node size. Next, we define some networking here. So basically, network on which you will deploy these worker nodes and master nodes. So you have to define some, of course, IP ranges, subnet mask, DNS server, the common networking that you would have to do in this. In my lab, I'm running one of these networks here, one of the segments. I will define the IP addresses here. I'm going to fast forward a little bit. It's a lot of typing here. So you can see that I give all the information, gateway, DNS server, NTP server. Then after this, I have to select the workload network. This is where the Kubernetes workloads will be deployed. So a switch, again, an edge cluster, some more networking information. The information that we are really interested in is here. Let me fill this up first, and I'll pause it for a second. So here we have basically port siders. So this is an internal IP address range, which is going to be supplied by Entria, and this is non-routable, right? So all the pods will receive an IP address from this range of addresses. This is not going to be visible from in your network outside. We have a services sider here, so all service type Kubernetes services will pick up an IP address from this range. And then you have two types of siders here. One is called ingress, and one is called egress. So all the traffic coming in into your Kubernetes cluster, hitting a layer 4 load balancer, it will pick up an IP address from this range. And any egress traffic is going to leave with an IP address source natted from a range from this pool of IPs here. Okay, this is what you have to do in terms of networking. It is of course going to be different for in each environment. So once you have done this, let me fast forward it to the actual cluster storage part. So then you have to basically select your storage. In my case, I just have vSAN. So I just selected that as my storage for, control plane nodes, ephemeral disk, image cache. In your case, in production, it would obviously be a bit more complex than this, and you would have different types of storage. So you review your configuration, and once everything is done, you can just basically deploy. It takes about 30-40 minutes, depending on how fast the machines are. It will have Kubernetes enabled on your cluster, and you'll have your supervisor VMs, and you're going to have your namespaces. Okay, so this is how you enable workload platform in vSphere 7. In terms of cluster namespace and guest cluster creation, there's another video of that as well. So let me fast forward this. So now you have your supervisor control plane VMs running. So we'll fast forward a little bit here. You can see the Kubernetes cluster is running 4 hosts, Kubernetes version running inside this as well. This is actually quite, I did this some time ago, so it's an older version of Kubernetes. So I'm going to create a namespace here. This is a vSphere namespace. I give it a name, namespace -01. It can be anything you like based on department or application, whatever you feel like. And then once you have created this namespace, you add some users here, administrator, DevOps role, edit roles. You do all of that. Once you have done this, you can then go ahead and assign storage to this namespace. Once the storage is assigned, you can also set some quotas, CPU, memory, storage if you like. And after that, your namespace is created. So you go back to host and clusters view, you can see namespace 1 is created here. At this point, you can actually download the kubectl tool on your Windows, Linux machine, wherever you are connecting from. Then you can log into your cluster using the command line here. So you can see that, deploy pods here. And I can show you the file of how we created it. So this is basically logging into the cluster. And this is the manifest file here. I don't know if you can see this clearly, but this is the manifest file which is deploying the Kubernetes cluster inside the namespace. So I just give basically the count of control plane 1, worker nodes, CNI, etc. And then I run kubectl, apply, and give it the file name. And it's going to go and create this cluster for me in Kubernetes. Okay, so now my cluster at the end of like 20 minutes or 15 minutes, my cluster is going to be up and running here as well. Okay. And finally, I have the application deployment. So this is basically deploying pods inside on the ESXi servers. So let me fast forward. You can see that These are the namespaces. Clusters are created. So I'll fast forward a little bit. I'll create another namespace called complex application. Fast forward, do the same thing again, check storage, users, connect to this namespace, log into the supervisor cluster. And once I've logged in, I can go to my YAML files. I see there's a bunch of YAML files here, which are my Kubernetes manifest files. I will look at my namespace, kubectl get namespace. This shows me all the namespaces that I have in my cluster. So I'm looking at complex application. And now I'm going to actually go and apply the manifest file for this particular application inside complex namespace. Okay, it's going to create this application. So it's a Redis cache, it's a bunch Apache web server, a bunch of other things, and this you can see is deployed in my Kubernetes cluster. And then I can just basically, change the context here. I hope you can read the screen, though it's very small. So you can see this particular application has an external IP address, a layer 4 load balancer assigned to it, 192.168.50.5. So I can then go ahead and, load this application in my browser, and it will be running. So I hope that you can see how simple it is to run Kubernetes on vSphere 7. It's just a matter of enabling it. It's not really even installing it in a traditional sense. It's more like enabling it on a vSphere platform, vSphere 7. And it's just a matter of like within a few hours, you could be up and running with a Kubernetes cluster on vSphere 7. So when you deploy these Kubernetes pods on vSphere 7, it gives you a lot of visibility. As you can see, you can look at the pods running. You can actually do a lot of monitoring. You can do some additional quota management here. So you can set some more quotas here. So you can go down to even Kubernetes level and define some limits on a particular namespace and how many pods you can deploy, how many deployments, daemon sets, etc. And you can also see that I can look at the manifest of the application that I just deployed. So you can actually kind of reverse engineer and look at the manifest of a deployed application. So I think I've got tons of videos for everything here, which I did in my lab. But I think for today it's quite late, and for all of you as well. So we can stop it here, park it, and I hope that you liked it enough today for us to do more sessions and do more deep dives into specific topics. I know one of you requested for developer experience on this platform, which is one topic we have now. If any of you are interested to know more about other aspects of Tanzu Kubernetes Grid, such as storage, networking, lifecycle management, day 2 ops, etc., we can have more sessions later on and address those in detail.
Thank you so much, Zahur. And if there is no other question, I think it's time now, and definitely we will come back with the VMUG leaders here in Saudi with the more sessions related to Tanzu and Kubernetes, and we will get back again soon. So I think with this, I really would like to thank you, Zahur, and Salim, and Salah, and Karam, and special thanks to our all attendees who had time to attend this session and for their interaction with us today. So Thank you so much, and wish you all like a great evening.
Thank you all. Thank you.
Thank you.
Thank you.